Okay, example 3. For each of the points above, state 3 coterminal points. When compete, I think that's supposed to say complete, you should have 4 points that are all in the same place. So both of our values here need to be positive. This is the polar point it gave us, 4 comma 5 pi over 3. Both of those are positive. The next one they want is for your radius to be positive and your radian to be negative. Well, in order to do that, remember 5 pi over 3, that is a rotation this direction, and then we get to that terminal ray. If we go in a negative direction and stop at that terminal ray, that is a negative rotation of pi over 3, remember? So negative pi over 3 would get us to the exact same point. Now for these next two examples, notice they want your radius to be negative. So this time they're both going to be -4. They want one of your radians to be positive. They want the other radian to be negative. Now, what we're going to need to do here is we need the opposite terminal ray of this one in pink here. Make sure it's in the same family, though. So whenever I draw my opposite terminal ray, it needs to have a denominator of 3. We already know that our radius is going to be -4 for these. That rotation from here to here, that's 2 pi over 3. That's positive. So this one's going to be 2 pi over 3. And then if we were to go in the negative direction from here to here, that direction would be -4 pi over 3. So those are your answers for example A. Okay, for example B, they gave us the polar coordinate 3, 0. Here's the terminal ray going towards 0. 1, 2, 3, that's where our point would be. So I just plotted 3, 0. They want us to have the exact same radius, positive here, but they want the angle to be negative. So in order to achieve that, we'd have to go all the way back around the unit circle in the negative direction and then stop once we get to that terminal ray. That would be -2 pi. Here, they want your radius to be negative, but they want your angle to be positive. So we're going to use the opposite terminal ray here. So from here to here is pi rotations. And then we would want to retreat back from that angle 3 directions, which is why our radius is negative here. And then for this example, they want your radius to be negative, your angle to also be negative. So in order to do a negative rotation and then stop at that terminal ray there, that would be -pi. For the next example, C, they gave us -2, 5 pi over 4. Here's where 5 pi over 4 is that terminal ray. From the origin, we had to retreat. We had to go in the opposite direction 2 spaces. Let's start here. They want our radius to be positive. They want our angle to also be positive. So I'm going to go ahead and graph the other terminal ray. So in order to have a positive radius of 2 and a positive angle, once again, I drew that terminal ray that we're going to have to use in order to solve this problem. From the positive x-axis, we would rotate pi over 4 radians. Going back to the origin, we'd want to then go towards pi over 4 2 spaces. So this is pi over 4. Here, they want your radius to be positive and your angle to be negative. So then we would go in a negative direction this way, stop at that terminal ray. Now that is a negative rotation of 7 pi over 4. And then lastly, they want your radius to be negative and they want your angle to be negative. So we're going to be using this terminal ray here. We just have to go in a negative direction. If we go this direction and stop, that is a rotation of -3 pi over 4. And then once we get to negative 3 pi over 4, going back to the origin, we would retreat 2 spaces away from that angle. So those are your answers for C. And then the last one here, we have 1 comma negative pi over 2. Here's where negative pi over 2 is from here to here. That's a rotation of negative pi over 2. I went ahead and drew that terminal ray. So if this is going towards negative pi over 2, we would want to go towards that direction 1 space. Here, they want radius to be positive and your rotation to be positive also. Well, we went from here to here in a negative direction. So if we go from here to here in a positive rotation, that would be 3 pi over 2. Now they want your angle to be negative and your rotation to be positive. So we're going to have to use the opposite angle now. So we're going to rotate towards that terminal ray in a positive direction. That would be pi over 2. And then from that, if we rotate towards that terminal ray at pi over 2, going back to the origin, we would then want to retreat -1, which is what we did. We have a negative radius there. And then lastly, they want your radius to be negative. They want your rotation to be negative. So we're going to be using this terminal ray again, except we're going to be going in a negative rotation this direction and stop. That would be -3 pi over 2. That is example 3.